Hey everybody. What I've got here for example 2 is a pretty typical problem that you would run into. Um, and let's read it and see if it feels like a binomial question. Because remember, these come mixed up with other probability problems and that's sometimes hard to detect, but I think we can see it in this one. A quiz has 6 multiple choice questions, each with 4 choices. If you guess at every question, what's the probability of getting 5 out of 6 right? All right, now how can a multiple choice question be a binomial where it has just 2 outcomes, and the way that is, it's either correct or it's not. Okay, so it's either correct or it's not. So that's what creates the binomial there, and then you got your trials, which is there's 6 questions. They're independent of each other. Now we can calculate these probabilities. So let me show you how to set this one up. I'm going to write this down, and we'll go to the pad here, and we'll kind of get in here and see what we can do. All right, so first of all, P of, let's say correct, is P of C. Well, there's 4 choices, so one of them's correct, we're assuming, and that's a 1/4. P of not C, which is not correct, we know now is 3/4, right? All right, now it says what's the probability we get 5 out of 6? Well, there's 6 trials. Let's just write that right here. N is 6, so it's 6 choose 5 times what, 1/4 to the 5th times 3/4 to the 1. And I calculated that to get approximately, I know everybody can put that in a calculator if they need to. 0.004. So that's a fairly unlikely event. Good luck on that one, guessing on all those questions. Okay, so that's one typical problem I wanted to do with you. And there's one more that I'm going to do that's going to be a little more complicated. So that I hope I didn't rush through that. But I want to get them into one video, okay? All right, so the next one, let's go look at it before we talk about it. The next one's a little more complicated. It looks wordy, and it is. It says 8 out of 10 nutritionists recommend brand X. If nutritionists A, B, and C are asked their opinions on brand X, what's the probability that at least one of them recommends brand X? Okay, so when we go to work with something like this, we got to start trying to extract the information of how many trials are there, where do my probabilities live, and things like that. So we're going to say that what makes it binomial? Well, it's either going to be recommended or not. So that's how that works. And then the probability of recommendation looks like it'd be 8/10, which is or 0.8, and not recommended would be 0.2. So with that, we start looking at what are the trials then? Well, trials would be A, B, and C, wouldn't they? Okay, so there's 3 trials going on here, and it looks like they want to know the probability of at least 1. Well, at least 1 sounds like 1 could be right. I mean, 1, we would need 1. It could be 2, or it could be 3, and this is an or. So we're going to sum these up. And I got a couple of ways I want to show you to do this. So I wanted to get right to work here, and I have a calculator trick for you. I know some of you like those when I want to show them. Okay, so the way that we can start working at this is we're going to say the probability of brand X is actually 0.8, right? And probability of not X is 0.2. And we're going to say N is 3 in this case because we're doing trials A, B, and C. All right, so now let's start calculating what would happen if it was one of them, which is an acceptable thing. It says at least 1, so we have to include 1. 3 choose 1 times 0.8 to the 1 times 0.2 to the 2 All right, then we'd have to say, what if it was 2 of them? Times, a pen messed up, 0.8 to the 2 times 0.2 to the 1. And finally, we need to add to this 3 choose 3 times 0.8 to the 3. So it's a mess, right? It's a lot of work, a lot of calculation there. And I calculated this earlier, so I don't use up all this video time. 0.992. All right, so let me show you a way to enter this into the calculator. It might save you some time if I don't mess it up. And it goes back to the way we were calculating some of those binomial coefficients in the other unit we were in. And let me just minimize this and I'll show you what I'm talking about. One way to enter this in the calculator is go to math. You get you a sum because you're going to sum something up, right? And we're going to start it at 1 because we started at 1, and we're going to add up to 3 of them. Oh, where's that thing not going up there? Come on now. What in the world? All right, now we're going to need to get, just like we did the binomial coefficients in the other unit, we have 3 choose x. So we're going to go to math, get this thing to choose one of these for me. And now we want to do our 0.8. And that's going to be to the x. And 0.2, I'm going to raise that to the n minus x, which is 3 minus x. This might seem a little bit time consuming, but I still think it's faster than doing all that calculating. It might not be. You might could have copied and pasted it back and forth pretty fast too, honestly. So, I just throw that out there for you. If you're into shortcuts and you like to learn new things, that might speed you up some. So that's it for this video. I don't think I have another one of these in this binomial probability. Let me know if you have trouble. There is an IXL that goes with this, and I think it's set the standard at 80. So if you get an 80, that's 100. Anything below an 80 is whatever you get. So if you get a 79, I'm putting in a 79. All right. See ya.